Hello everyone, and welcome back to Budi Network Academy. In our previous video, we learned what a VLAN is, why we use VLANs, and how VLANs help us separate a network into different broadcast domains. Today, we are going to move from theory to practice. We are going to build a simple VLAN network, configure the switch, connect our devices, test connectivity, and troubleshoot a VLAN problem. So, let's get started with our practical VLAN lab. Before we start configuring, let's look at what we are going to accomplish in this lab. First, we will create two VLANs. Then we will assign switch ports to those VLANs. After that, we will configure IP addresses on our computers and test communication between them. We will also verify our VLAN configuration and finally troubleshoot a simple VLAN problem. The idea is to follow a very important network engineering process: configure, verify, test, and troubleshoot. Here is our lab topology. We have one network switch and three computers. PCA and PCB will belong to VLAN 10, which we will use for the IT department. PCC will belong to VLAN 20, which we will use for the HR department. We will also give each computer an IP address. PCA will use 192.168.10.10. PCB will use 192.168.10.20. And PCC will use 192.168.20.10. Notice that the devices in VLAN 10 use the 192.168.10.0 network, while the device in VLAN 20 uses the 192.168.20.0 network. Now, let's start configuring the switch. Our first step is to create the VLANs on the switch. We will create VLAN 10 and give it the name IT. Then we will create VLAN 20 and name it HR. The VLAN ID identifies the VLAN, while the name simply helps us recognize its purpose. Next, we need to assign switch ports to them. Now that our VLANs exist, we need to tell the switch which ports belong to each VLAN. PCA is connected to Fast Ethernet 01, so we will assign that port to VLAN 10. PCB is connected to Fast Ethernet 02, and we will also assign that port to VLAN 10. PCC is connected to Fast Ethernet 03, so we will assign that port to VLAN 20. These are access ports because they are connecting end devices to the switch. Our switch configuration is ready. Now we need to configure the IP addresses on our computers. PCA will have the IP address 192.168.10.10 with a 24 subnet mask. PCB will have 192.168.10.20 also with a 24 subnet mask. And PCC will have 192.168.20.10 with the same 24 subnet mask. For this simple lab, we don't need to configure default gateway yet, because we are only testing communication within the VLANs. Once the IP addresses are configured, we are ready to test our network. Now comes the interesting part. Let's test whether our devices can communicate. First, I will test communication between PCA and PCB. Both computers are in VLAN 10 and they are using the same IP network. Then I will test communication between PCA and PCC. PCA is in VLAN 10 while PCC is in VLAN 20. Now let's verify that our VLAN configuration is correct. On the switch, we can use the command show VLAN brief. This command allows us to see the VLANs that exist on the switch and which ports are assigned to each VLAN. Now let's introduce a small problem. Imagine that PCB suddenly cannot communicate with the PCA. The IP addresses look correct. The cables are connected, but the ping is failing. Where should we start? One thing we should check is the VLAN assignment. Let's imagine that PCB's port was accidentally assigned to VLAN 20 instead of VLAN 10. Now PCA is in VLAN 10 while PCB is in VLAN 20. That would explain why the ping is failing. So let's verify the VLAN configuration and find the problem. We have found the problem. PCB should be connected to VLAN 10, but its switch port is currently assigned to VLAN 20, so we need to correct the port configuration. This is a simple example of real network troubleshooting. We identified the problem, checked the configuration, corrected it, and tested the result. Configure, verify, test, troubleshoot. Let's take a look at our final network. We have one physical switch, but we have created two separate VLANs. PCA and PCB are members of VLAN 10. PCC is a member of VLAN 20. PCA can communicate with PCB because they are in the same VLAN and the same IP network. PCA cannot communicate directly with PCC because they belong to different VLANs and we haven't configured layer 3 routing. So we have successfully created a simple VLAN based network. Let's review what we did today. We created VLAN 10 and VLAN 20. We assigned switch ports to the appropriate VLANs. We configured IP addresses on our computers. We tested connectivity using ping. We verified our VLAN configuration using show VLAN brief. And finally, we introduced a configuration problem and fixed it. The most important lesson is that configuring a network is only part of the job. A network engineer also needs to verify, test, and troubleshoot the configuration. This is the practical approach we will continue using throughout our intermediate networking chapter. Thank you for watching this practical VLAN lab. I hope this demonstration helped you understand how VLANs work in a real network and how we can configure and verify them on a switch. In our next episode, we will continue with VLANs and learn about an important topic: access ports, trunk ports. We will learn what each one does, when we use them, and why trunk ports are important when connecting VLANs across switches. If you found this video helpful, please like, comment, and subscribe to support Budi Network Academy. Until next time, learn, troubleshoot, connect. I am Budi, and I will see you in the next video.